Section 8.2, Critical t-values. Please review the PowerPoint slides located under the resources. The t-value can be found in Table A3. Notice I've got some yellow marks already on Table A3. This goes with some of the examples that I'm going over. So let's go over some examples. Find the critical value t alpha divided by 2 needed to construct a confidence interval given 99.5% confidence and a sample size of 5. The first thing you have to do is, we're using the t critical value because we do not know anything about the population. This assumes that everything is a sample. So the first thing you need to find are the degrees of freedom. The degrees of freedom, which is df, is equal to the sample size minus 1, or n minus 1. In this case, our sample size is 5, so 5 minus 1 is a 4. Next, on Table A3 at the bottom, use 99.5% and find 4 on the left side. The intersection is the answer. So if you look for 99.5%, that's third over from the right side, and you go up to 4, which puts us right here. So 99.5, so I'm basically going up from there. So that gives me a value t of 5.598. Find the t-value given 90% level when n is 15. So first thing you do is find the degrees of freedom. 15 minus 1, again the sample size is 15, so that puts us 14. So 90% at the bottom of Table A3 and 14. So again, 90% is right here, and then I go up to 14, which is right around there. That's my number. So that's going to be 1.761. Next, let's try 80% with a sample size of 30. So again, I go the degrees of freedom n minus 1, so 30 minus 1 is 29. 29 at 80%. So 80% is here, 29 is here. So the intersection is right there. So that is at a value of 1.311. Another example, find the confidence interval. Sample size is n equals 52. The sample mean, notice they're telling us a sample mean, not a population mean. It's 53.4. Sample standard deviation is 9.4. Again, all sample information is given. I want to construct a 90% confidence interval for the population mean, round to 1 decimal place. First thing I do is I get the degrees of freedom. I do 52 minus 1, which is 51. Notice 51 is not in the table on the left hand side. It goes from 50 to 60. So when the number's not in the table, you use the next smaller number. Even if it was like 110, you would use 100, or 199, you would use 100. So we're going to use 50 with 90% confidence and degrees of freedom of 50. That gives me a t of 1.676. Next, I need to find the margin of error. The margin of error is going to be this t-value times standard deviation divided by the square root of n. The square root of n is n, not the n minus 1. So I take the 1.676 that I just found, I multiply it by 9.4. 9.4 is the standard deviation, and again my n is the square root of 52. So 1.676 times 9.4, the square root of 52 is 7.2. Then I divide 9.4 divided by 7.2, that gives me 1.31. So now I do 1.31 times 1.676 to get 2.12, but they want us to round to 1 decimal place, so it's 2.2. Now I have to find the interval. So I put the mean in the middle. The mean was given as 9.4. And to get the interval, it's the same process as the last section. I'm going to take the mean minus the margin of error and the mean plus the margin of error. So I'll go 9.4 minus 2.2, which gives me 7.2, and 9.4 plus 2.2, which gives me 11.6. So the way I would read this is with a 90% confident, or I am 90% confident that the population mean is between 7.2 and 11.6. So as the sample size increases, the margin of error decreases, the confidence interval narrows. If the sample size decreases, the margin of error increases, and the confidence interval will widen. As another example, a sample size of 256 students asked their opinion on a course. The average score was 5.25, and this was 1 out of 7. Standard deviation is 0.85. So I want to construct an 80% confidence interval, and I want to round to 2 decimal places. First thing I do is find the degrees of freedom. So n minus 1, n is 256. 256 minus 1 is 255. Again, 255 is not on the table, but because it's greater than 200, I use that last row on table A3. So the last row on table A3 is this one down here. So I match that up with 80% confidence level, and that is 1.282. Then I find the margin of error, so it's going to be t, the critical t value times s over square root of n again, so it's 1.282. That's what I looked up on the chart. Standard deviation was 0.85, and again my sample size, I used the 256 number, so square root of 256. Square root of 256 is 16, so 0.85 divided by 16, that gives me 0.053, and I multiply that by 1.282, and I get a margin of error of 0.068 or 0.7 because they want me to round to 2 decimal places. Then finally I get the interval. Again, I put the mean in the middle, and it's going to be the mean minus the margin of error and the mean plus the margin of error. So 5.25 minus 0.07 gives me 5.17, and 5.25 plus 0.07 gives me 5.32. Assume the mean score for other students is 5.21. Does the confidence interval contradict the claim? So pretty much what you're doing is looking to see if the number they give you is between the two numbers you just got. So is 5.21 in between 5.18 and 5.32? Yes, it is. So since it's within the above confidence interval, it does not contradict the claim. And on another note, if the number is outside of the confidence interval, it will contradict the claim. Meaning if they would have given me a number of, let's say, 4.2, 4.2 is not in between 5.18 and 5.32, so that would contradict the claim.